I'm super happy to be here. I think today, or this morning, we are going to talk about the topics not on the screen, and I have to remember 5 topics today, but this one is about the digitization of agriculture, and I'm sure we are going to zoom in satellite IoT as well, as we have some folks from Lacuna Space here. A very hot topic. I'm actually surprised that it is a hot topic again, because it was a hot topic 3 years ago. And what I remember is, like in general, the market was a bit disappointed because of accessibility problems, cost problems. But it looks like the satellite IoT concept is back. And I'm sure it's being used all over the agriculture industry, so I would love to hear more about that. But before doing that, a short intro. I'm Afzal. I'm in between jobs right now. Used to work at Deutsche Telekom running my own startup. And now I'm just enjoying my free time by doing panel discussions here at this conference. Over to Eric.
Hi everybody, I'm Eric Hewitson, Business Development Manager at Lacuna Space, based in the UK and the Netherlands, and we are a satellite operator for the Internet of Things.
Hi, I'm Mattia Fiumara. I'm with Agurotech. We develop soil moisture solutions for agriculture, hardware and software solutions.
Hi, I'm Hilary Heath. I work for Digi International. We manufacture gateways and nodes and a LoRaWAN network server in the cloud. So we address it from the solution side as well as a modular side.
Thanks for the intro. Let me sit next to you. Let's just start. How is it going in general with the adoption, if we look at agriculture, Eric?
Well, I think the big questions for agriculture are the tyranny of distance, the remoteness of so much of agriculture, and the fact that we are on the cusp of going from 8 million population to 10 million population in the next 20 or 30 years, probably peaking in 2080. Unfortunately, between now and then, we're probably not going to add very much agricultural land. So there's a bit of a crisis there. How do you feed those extra mouths? And on top of that, you've got the problem that diets are changing across the world as in particular Asia and Africa start to consume more meat protein-based products. That's putting extra stress on agriculture. And if you look at the overall land, the overall habitable land on Earth, about 40% of that is agricultural land. And of that, only a third of it is crops. The other 2/3 is actually livestock. So how do we meet that? How does agriculture meet that demand is the question. And I think that's where everybody in this room's got a really, potentially an important role to play, because obviously one of the key things is going to be data and digitizing agriculture. And I mean, the UN FAO, Food and Agriculture Office, they're saying that we need to have an uplift of just over 1% per year in terms of yield to be able to meet that demand on the same land. So if you're doing 1%, in a cumulative way over that time, you can meet it. But that's actually a big ask to do that. And at the same time, you've got the other pressure coming from the other direction, which is the sustainability question, the fact that soils are under pressure, the fact that water stress is manifest across the world. So I think that's the challenges that are there. Yeah, I mean, I can talk about satellites, but maybe...
Maybe Hilary wants to add something.
Well, I agree with everything you just said about sort of the consumption of protein being up across the world and in the United States. So I'm going to talk mostly from the United States side. Hopefully you can find something relatable in this, but and I'm going to talk a little bit about it when we go through this. But we're doing a livestock field trial right now, which I'll go into in more detail. But I think so in Texas in particular, which will be the area that I talk about, livestock is huge. There's over 10 million livestock cattle in Texas, and they're we're not talking about range animals, so we're not really worried about where they are from a geolocation perspective. We're really worried about them being sort of like, if you picture sardines in a can, that's often how cattle are raised in the United States. So these cows don't move a lot, and they go from birth to death in about 14 months. So the objective is, feeding them, keeping them healthy, getting them from birth into, production. And then into the mouths of people in a very short amount of time. And in order to do that, you have to keep them healthy. And so that's what we're going to talk about, our LoRaWAN solution, and how we're addressing, the data that you want to collect to keep those cattle healthy.
Do you want to zoom in on some use cases in agriculture?
Yeah, so we are working with in the end customers when mostly on arable farming, and we're trying to optimize soil moisture, water management, trying to reduce the amount of resources that farmers are using technology. And we've been using a number of different type of technologies for that, looking at cellular technologies and also LoRaWAN. And Eric invited me here to talk about satellites, how we could use that for the end customers, and I think that's has its own challenges. I think you also mentioned cost and the other challenges like round trip time. I was asking in the audience, some applications don't really need that, don't really need the real-time performance of a cellular network. But if you look at, for example, soil moisture, it can stay the same for days. But if you look more in applications like frost monitoring, where you really need to act within the hour, then these solutions are becoming more of a challenge to use. So that's kind of what we're exploring, how what kind of use cases we could use cellular technology or satellite technology.
I'm just wondering, do you think that like satellite? It's just a very simple question, but would you say that agricultural use cases are not possible at all without satellite IoT connectivity?
No, I wouldn't say that at all, but I can give you a nice story about somebody who's now decided that they're going to work solely using satellite technology. And I think it's a combination. If in this situation where you've got concentrated activity happening, it makes sense to have a cellular service, even if you're in a remote location, put up a cell tower, perhaps that's not a big CapEx expenditure for your whole operation. Why not do it? Absolutely. But there's no question that large tracts of agricultural land are just too difficult really to do with multiple gateways everywhere. And the thing that I've really, talking to farmers, talking to those end users, they don't want to be network managers. They don't really want to employ a company to be, an IoT company to come in and set up networks and maintain them for them. They're quite happy to deploy a sensor. That's fine. They can do that. They're used to that and they need it. But they just want to see the data in their phone or on their laptop or on their tablet. They're not really interested in anything that comes in between that, and that involves the infrastructure, the terrestrial infrastructure, or the satellite infrastructure. It's just that the satellite infrastructure kind of works everywhere. So the use case I'm thinking of here is a German seed producer, the fifth largest seed producer in the world, and they have thousands of fields where they're running trials on different seed variations for everything from row crops, grains, etc., but also vegetables and sugar beet, all these kind of key important crops. They need very accurate data for soil. We're using kind of sensors that Mattia and Agurotech use, sensors at depth, humidity, temperature, going down 10 centimeter readings down to up to 90 centimeters, that kind of thing. And it's only with that data that they can then run these models and know what's performing best, what isn't performing best, and what seeds can then go to market. When they were having to, they started out using NB-IoT, they switched to LoRaWAN, running gateways, but there was always that need to add another gateway to get the distance required, and then it just became this sort of complexity for them that doesn't really sit their technical skill set. I mean, they're ag guys, they're agronomists, So when they started utilizing satellite technology with us, they just realized it's just easier. I can just put the sensor there, it's got connectivity and it works. And so now they don't worry about it. So I think that's where the really good use case for satellite comes in. And of course, it's global coverage, so you just don't have to worry about wherever the hell you are on Earth. And yes, satellite is back. Afzal, satellite is back.
I will come back to global coverage, but I mean, I know that there are some exceptions. For example, I live in the Netherlands, and yesterday I met someone who's doing sheep tracking. And I asked him, why do you need to do sheep tracking? Because I'm thinking about the Netherlands. There is a fence here and there is a fence there. You know, it's such a small country. You can always find back your sheep. But there are regions where you don't have fences. So I know that there are exceptions. There are places where we probably don't need satellite IT connectivity for agriculture. But coming back to global coverage, a couple of years ago I was working in the incubator of Deutsche Telekom. And we were working with startups from Nigeria, Tanzania, and a few other countries in the African continent. And they were working on very cool use cases to improve agriculture. But their problem was that there were no low power wide area networks available in their countries. So the operators, they didn't roll out narrowband IT or LTM yet. And no one was willing to roll out their own LoRaWAN network. So I'm just wondering, are we already doing things in the African continent these days in agriculture? This is a question to all of you, so who wants to answer first?
Yeah. So our product currently works on cellular technology, and we use that in African countries like Senegal and all North African countries. But indeed, like you said, LTE-M or NB-IoT is not always rolled out as well in every country. Some countries do have these technologies, but not all of them. And then you have to rely on technologies like LoRaWAN. But again, I mean, you mentioned that putting up a cellular tower is not big capex, but if we have to sell gateways to our customers, then that doesn't fit in the business model. It's just too expensive if they only have maybe 2 fields to monitor, for instance. So I think this would only work for really big corporations, and they could potentially have the money to invest in these kind of things. But then, yeah, for the smaller farmer, that's just not an option. So I think I guess satellite communication could work really well in these in some countries. We've also have some deployments in more Central Africa, and here it's sometimes really there's no cellular infrastructure at all. So we really have to look into different solutions in those kind of regions. Sure.
Yeah, no, I think it's a great question. So I guess what I would say is from our perspective, so in the United States right now, satellite isn't approved for LoRaWAN. We can't take a downlink. So we do address our solution from the cellular backhaul side. Should I go into any detail about our particular solution at this point, or do you want to get to that later? Yeah, okay. All right. So I did share some slides, but they might not have made it. This was sort of I'm a last minute ad, just so you guys know. But the way we addressed this particular customer solution was around temperature monitoring and health safety for these massive herds of cattle. And so this is really at scale. This is, these are there's a lot of money in livestock cattle in the United States, and really bankers own these cattle. So it's really the value statement is to the bankers. There's ranchers, and they have their stake as well. But the real, the person you're making your value statement to is the bankers that are funding all of these efforts. And so, again, if you paint the picture of what livestock cattle look like, for example, in Texas, people have herds of like 30,000 cattle clustered together. I mean, there's I think one ranch that's like in Mexico that's 1 million cattle. So that's, massive scale, right? But we're talking about these, I guess you could call them deployments of livestock. And these cattle, our way of addressing them is we had to work into their normal workflow of how they would work with cattle. And so you've probably all seen these ear tags that, you see it on other livestock as well. But in the United States, if you go to a cattle ranch, you'll often see 2, 3, 4 different tags on these cattle's ears. I mean, their ears are property. It's like, think of it like, tagging anything else, right? So their ears hold all this different information. And so we worked to create a solution that's all the way from the tag to the cloud to the analytics to the customer. So from Digi, we addressed the full solution for this particular customer. So we're using our XB-LR, which is our LoRaWAN end node, and we've incorporated that into an ear tag. And then from a workflow perspective, these ranch hands have to get an ear tag into a cow's ear in a matter of seconds. So they shove these cattle through these sort of chutes. So again, like picture any Western you've ever seen maybe about cattle coming through a chute, but these ranch hands are not technical people. They're often people for hire for a period of time and then they move on. So we had to address this from how can we make this as simple as possible and address this from a how do we work into their workflow. So they've got an ear tag. The tag has a probe, and the probe rotates and sits deep within the ear canal of the cow, and that's how the temperature monitoring happens. And then the LoRaWAN radio communication device is on the outside of the tag and communicates back to a gateway, which is cellular connected to the cloud, and that's where we're deduplicating and pulling, translating that data over into an analytics platform. So yeah, we have done some field trials. We've got another field trial coming up in October, so a couple weeks. We did one in May, and you guys talked about or mentioned that we could talk about things that didn't work, and I think sometimes that's a really important part of this, right? And so we spend a lot of time with our particular customer stakeholder looking at their requirements and designing this ear tag with this temperature probe. And what we learned when we did, early field trials is that, yes, we can get these sort of non-technical people to, kind of pierce the ear of the cow in that 30-second time slot or less that they've got to get these cattle through this chute, right? They, just so you know, too, at the time they're tagging their cattle, they're often vaccinating them as well. So there's a lot happening to that poor cow as it goes through the chute and gets sent out the other side, and then the next cow comes down. And I would ask you also to picture the scenarios of, in Texas, it could be anywhere from, 43 degrees centigrade in the summer, so extraordinarily hot conditions in Texas, to, the day of our field trial, of course, it had been raining all week. So we were standing knee deep in mud, the wind was blowing, everybody was soaking wet. And so, we're trying to get these ear tags in the cattle. And what we experienced with our first field trial is that because of all these other things happening to the cattle, they're pretty pissed off. Like really pissed off. So they come through the thing, they're getting shots, sometimes they dehorn them, they clip this ear tag in, they shove the probe deep into their ear and they shoot them out the other side of the chute, and they go into a big pen. So they come through that pen bucking, twisting, shaking their head up and down like mad. I mean, they just look like a frenzied animal, and those probes didn't stay in their ears. So, we were like, oh my God. They're on a pivot. The hope was that as they shook their head, that the probe would move within their ear, and especially because it's fairly long probe. We had some percentage that stayed in. We had some percentage that just shook right out of their ears. So in order to get the data, and we got data flowing immediately, which was very, very cool, but we had to manually go back and try to shove some of those probes in the ears, which is not practical and not at all what we were shooting for with that particular one. So we've been working with, the toughest part of this solution is it's a wearable. So you also need to step back. It's livestock, it's ag, but it's a wearable. It's just a wearable for animals. And you can't tell an animal to keep it in their ear because, hey, we need to collect your temperature data, right? So that's some of the challenges, that we had. And just so from a use case perspective, the reason this is important is that our plan is over time, we're not only monitoring the temperature of these cattle, which if one of these cows gets sick, in this sardine can type scenario that they're living in, it spreads like wildfire through the herd. So if one cow goes down and gets sick, before you know it, you've got 1,000 cows that are down sick. And in most situations, they pull them and destroy them. They can try to vaccinate them and quarantine them in separate areas, but it's a business. And it really kind of depends on the age. If it's a young cow coming through, maybe in the first 6 months, they may opt to just destroy the cow versus a cow that's closer to going to the slaughterhouse and going into the food community, so they might at that point take it and vaccinate it. So what we're trying to do is catch these, early warning signs of a temperature up to 72 hours prior to the cow actually getting sick. So we can start through machine learning, learn what to look for in terms of sign for these being sick. So yeah, it looks like I probably need to pass this off to the next person. But Jordan and I are here at the show. Jordan's sitting somewhere back here. So yeah, hopefully you'll come and chat with us a little bit more about that. And hopefully, if I come back next year and we can talk about the success of the next couple of rounds of those probes going in the ears and actually staying in.
Maybe then, maybe just in 30 seconds, question to both of you, Mattia and Eric. Do you think that like from a satellite IoT perspective, from an end-to-end perspective, we are ready now to serve and develop most of the use cases of today?
Well, I think absolutely. I mean, livestock has its challenges, that's absolutely for sure. But there's a lot that comes with raising livestock, and a big part of that is the feed. So I've just actually come back from Algeria last week, and I had a conversation with the CEO of what is going to be the world's largest dairy farm in Algeria. It's funded by some guys from Qatar and the Algerian government, 270,000 hectares. Just to give you an idea, the largest farm in the UK is 10,000 hectares. Yeah, these are massive, and they're putting up a huge 5G mast. They're doing, this is a multi-billion-dollar project. But to feed that number of cattle, they've also got massive, in the same location, massive pivot farms with huge soy production, and these. This requires monitoring from soil moisture sensors, weather, the weather data, the soil NPK, all of this stuff together needs to come together. A lot of this can never be inside the cellular range potentially, and there's always cases where it isn't. I think it's a combination of working terrestrial and satellite, but satellite picks up everything else, and it just makes things a lot easier, and it's ready and it's happening.
Great, thank you. Any last comment from your side?
Yeah, so I think NTN or satellite communication can definitely achieve all the use cases in agriculture, but there's a huge but, and there's an expectation from the end customer, and they expect the data to be there as soon as they install the sensor in the field. They need immediate response, and I think, yeah, there's still a gap there which we have to somehow cross. Yeah, and I think that's.
Just one last word. I mean, the thing about Lacuna Space's offering, you've got a box like that. It's low power, just like terrestrial LoRaWAN is low power. It's the same power issue. So you're just solving that problem of connectivity, but with the same power that you would otherwise have.
Thanks, guys. I have many more questions, but we have to go to the next ones. And don't leave, because these are two of my great friends, and they're great speakers, and the topic is very exciting.
Thanks, Afzal.